There's common a misconception between weight and volume when it comes to buoyancy. Often young children experience the inability to explain volume without using the term weight. When children are asked to explain why a larger item displaces more water than a smaller one, they often refer to the item's weight and not the volume like they should. The second misconception is the amount of water an object is immersed in can make a difference when it comes to buoyancy. Students make claims that if we put an object that sinks into a larger amount of water, such as a pool, that it may float. The third misconception is the idea of density. Integrating the two variables of mass and volume can often be difficult for students, so they have the grasp of weight and volume independently, but when it comes to them together and why they're making things float becomes more difficult. They often only attribute buoyancy to weight and don't think about the volume. And the last misconception has to do with surface area. Often students are convinced that floating objects must have air in them and that more surface area is exposed to water. So that is our last misconception. Our group was given the topic of buoyancy, and we are going to be testing the question, what design of a boat can hold the most cargo, and why does it stay afloat? So the materials we're using are tin foil, and we decided to do a 15 by 15 square of tin foil to make each of our boats. We have our pennies that we're going to put in one by one to test how many pennies the boats can hold. And then we have our tin foil holder of water that we're going to put the boats in to see how long they can stay afloat with the amount of pennies. So I worked on the boat that was a square. As you can see, the bottom is a square. So I kind of folded up each side so it would be more secure on the sides, and then instead of cutting it because the water may get in, we folded the sides in as a triangle and then folded it up to make the edges, and then I just folded it down once more. So this is our square boat.
So I tried to make a circular and rounded boat, so the shape of it is a circle, and then on the bottom I tried to round it out a little bit. I didn't cut the foil either, I just sort of folded over so it would have thicker edges.
This is the triangle boat. I've made this by folding the tin foil in half and folding the sides and then kind of popping out the center so that way it has a, I guess, stable surface to float on.
This is the rectangular boat. The bottom is a rectangle, and I just folded some sides in, and it's a nice dip.
So this is the data sheet we're going to be recording our evidence on. As you can see, it lists each type of boat that we're going to be using, and then it shows us trial 1, trial 2, and trial 3. So this is where we'll list how many pennies. So for trial 1, how many pennies the square held. And then at the end, we'll kind of do a average number for each, and that will kind of show us which boat is holding the most cargo. 1, 2, 3, 163, 164, 165, 166. Whoa.
Okay, this is the rectangular boat. 1, 2, 199, 200.
Okay, so this one is the circular boat. It's rounded on the bottom. 1, 2, 3, 220, 221, 222, 223, 224, 224. There's water getting in there.
Is there?
From two sides.
Oh.
Alright, this is the triangle boat or canoe. Alright. 1, 2, 3, 64, 65, 66, 67, 68.
I think it's on the bottom.
Nope.
How many?
52, 153.